to the video lecture series on stuck at faults. In the series of videos under testing of VLSI circuit, in the previous video we saw about stuck at 0 and stuck at 1 faults using the basic circuits like the AND gate and simple CMOS realization. In this video lecture, we can take two scenarios to explain the presence of stuck at faults. The function a plus b into c plus d plus EF, the whole complement, is realized using CMOS realization concept in this image. Before going on to stuck at faults and its understanding, let us first understand the CMOS realization of a function because it forms the basic for understanding the fault occurrence. So, a given function can be realized using CMOS logic by using transistors, PMOS transistors and NMOS transistors. When they are used in combination, we call it as CMOS circuit. Usually, the CMOS realization has pull-up network that is made up of PMOS transistors. This is the demarcation line and the output is taken as EZ. Below that is pull-down network which is made up of NMOS transistors. Number of transistors depends upon number of inputs. Here the inputs are A, B, C, D, E, F. 6 inputs are there. So 6 transistors at the pull-up network and 6 transistors at the pull-down network to receive the inputs are usually used in the construction of CMOS circuits. So 2n number of transistors are used for CMOS realization, n being the number of inputs. So here n is 6, so 12 transistors are used for construction. 6 is PMOS transistors and 6 is NMOS transistors. And how the transistors are connected? That again depends upon some basic laws. NMOS transistor, the AND gate is realized using series combination. OR gate is realized using parallel combination. Let us go back to the function a plus b, that is OR. OR gate is realized using parallel. So a is parallel with b. Here c plus d, so this is OR. So c is connected in parallel to d. In between a plus b and c plus d, there is an AND gate. So there is a series combination over here. Coming on to EF, which is E dot F, which is nothing but E and F. So they are in series. EF is in parallel with A plus B and C plus D. So we have connected as parallel. I think now you got how a pull down network, that is NMOS transistor, is connected. While going to pull up network, it is connected exactly opposite to that of pull down. Here if it is parallel, there it is series in the pull up. A and B are parallel, here it is in series. C and D are in parallel, here it is in series. E and F is in series, in pull up it is in parallel. EF is in parallel with these combination. Here EF is in series with this combination. So quite opposite to that of the pull down network, we have to connect the pull up network. This is the simple way of remembering the CMOS realization. But conceptually, if you take, this happens due to the De Morgan's law. If you apply the De Morgan's law, we can get how to get the pull up network. If you go for application of De Morgan's law into the whole function, a plus b the whole complement, c plus d the whole complement into e if the whole complement will happen. So if the whole complement can be written as e complement plus f complement. So if you look at this expression and if you go for connection, a plus b the whole complement can be written as a bar dot b bar. So A and B are in series again. C plus D, the whole complement can be written as C bar dot D bar. So C bar, because bubbles are here, C bar dot D bar. So E bar plus F bar, so parallel. Can you understand how this is happening? Based on the De Morgan's law only, we go for the combination, parallel or series connection of MOS transistors. Okay, I think you got how a CMOS realization happens. Now coming on to how the fault affect the circuit. Let us consider the examples. 110010. Here it is 1, here it is 1, here it is 0, here it is 0, here it is 1, and here it is 0. One more thing I forgot to explain. NMOS transistor will be on when it is given with the input 0. It will be off when it is given with the input 1. So at this particular case, This path is totally disconnected. Only C, D, and F are on and it is connected to Z, and we'll get the output as 1. This is fault freeze. Quite opposite operation happens. A and B will be shorted. Okay. Similarly, E and F. E will be on. F will be off. So when PMOS is on, NMOS will be off. This is how it is going to work. One means PMOS will be off, but NMOS will be on. So AB is shorted, this will be open, so this is disconnecting the ground. Here again this will be open and it is disconnecting the ground, so the final output is 1 for this combination. Let us assume there is a fault at this point. When the fault occurs, that is it shorts E and F, what happened is it's a permanently stuck at 0 faults because it is going to ground the circuit. Output is going to be 0. Even for this combination it is 0, and permanently it is going to be the stuck at ground fault, that is stuck at 0 fault for this circuit. Let us go for fault at 2. If there is a short over here, it is not going to affect this part. This is going to be turned on, Z is going to be at the output. Okay. If you consider an example, if there is an open over here, what happens? If there is an open over here, whether it affects the fault? No. But if there is an open over here, again we will not get 1. So, what I want to say from this is, again, the location of source are open affects the transistors operation. As a whole, it affects the overall functioning of the circuit, thereby resulting in simple stuck-at faults or maybe multiple faults. So again, based upon the occurrence of faults only, we can decide. So for explanation purpose, I have considered this as an example. Coming on to the scenario 2, Z1 is nothing but it is A dot B the whole complement. Z2 is nothing but C dot D the whole complement. Let us take, there is a short over here. What happens? A is parallel with B, which is in parallel with C, which is in parallel with D. Here all are parallel. Here AB is in series, which is going to be parallel with C and D. So the circuit is going to behave separately. It is not going to give us to NAND of A and B or NAND of C and D. It is going to give some exactly opposite output. So this is how the circuit is going to behave when a short is going to occur. So just for understanding purpose, it may be a single stuck-at fault or multiple fault. Again, it depends upon the short or open inside the circuit that is occurring. Thank you. Thank you for patient listening.